To rent a jet ski at Sam's costs $25 plus $3 per hour. At Claire's, it costs $5 plus $8 per hour. At how many hours will the rental cost at both shops be equal? How much will it be? All right. We could make X number of hours that you've rented, and we're going to make Y the total cost. So at Sam's, the total cost is $25 plus $3 per hour. And we're going to make Claire's, it's $5 plus $8 per hour. The question is, at how many hours will the rental costs at both shops be equal? When will the total cost be equal? So we're going to use that equal values method and set these equal to one another. So I have 25 plus 3x, set that equal to 5 plus 8x. And now this is pretty easy to solve for x. Subtract 3x from both sides, and we get 5x. Subtract 5 from both sides, and we get 20. Divide by 5, and you get x is 4. So we need to interpret that. If x is 4 and x is number of hours, so at 4 hours, okay, they will both be equal. And how much will it be? Well, we have two equations. We could choose one to plug it in. Y equals 5 plus 8 times 4. So the total cost will be 32 plus 5, $37. So you could write it out. At 4 hours, they will both be $37. All right. Next one. A full-length CD costs $13.25, while a single only costs $4.50. Okay. Joey bought some of each type for a total of $62.25. If he spends $17.25 more on full-length CDs than he spends on singles, how many singles does he buy? How many singles? Okay, so let's make X number of full-length CDs, and we'll make Y number of singles. Full-length CD costs $13.25, and a single costs $4.50. We don't know how many of each type he bought, but it was $62.25. So $13.25 times X plus $4.50 times each single will equal $62.25. Now this one was a little tricky, I think, for folks. If he spends $17.25 more on a full-length CD than he spends on singles, okay, he spends more on full-length CDs. So if our full-length CD amount that we spent is this is more than singles. So to make this equation balance, I'm going to put the singles over on the other side. That's how much he spent on singles. To make these equal, I have to add $17.25 to this side, right? Because he spent less on singles, so I have to add $17.25 to the amount on the single side to make this equation balance. Now I can go ahead and manipulate these so that I can solve the system. If I move this 450 over to this left side, it'll be negative, and then I'm going to be able to solve the system fairly easily. So this equation here, I have 1325x plus 450y is equal to 62.25. Oops. I don't know what that, oh, sorry. Now I'm going to move this 450 over here so it becomes negative. And now I'm just going to go ahead and I'm going to add these, right? Because if they're opposites, you add. So I add this, so I get 2650x. This is going to be 7950. And if I divide by 2650, x is going to be 3. So x is 3. That's full length full length. We don't want full length. We want singles. So now I need to plug this in to one of the original equations and see what I get. So, I don't know, let's go ahead and plug it into this one. 1325 times 3. Okay, 1325 times 3 is going to be 3975. We're going to subtract 1725 from both sides, so this is 2250. And we divide by 4.5. And y is going to be 5. So how many singles does he buy? 5. Okay. Next one. Okay. Jim swam 4 kilometers upstream in 4 hours, but his return trip downstream took 2 hours less. Find his swimming rate in still water and the rate of the current. Okay. So we have with the current and against the current. We have rate, we've got time, we've got distance. Rate times time is equal to distance. Make my table. Okay, so with the current, that means you're going faster. We have the rate plus the current. Against the current, we have rate minus current. Time. With the current, so going downstream, it took 2 hours less than 4. So that's 2. And against the current took 4. And we went 4 kilometers. Right? There's our distance. So I know this times time is 4. So I have time times r plus c is equal to 4. This is 4. R minus c is equal to 4. Okay. Now, instead of distributing, why don't we just divide both sides of this equation by 2, and it becomes r plus c is equal to 2. Divide both sides of the equation by 4, and I get r minus c is equal to 1. Right? If we divide this by 2, that goes away, and that becomes 2. If I divide everything by 4, that goes away, and that becomes 1. Now, I can go ahead and add c plus a negative c goes away, 2r is equal to 3. So that means the rate of the current is 3 divided by 2, which is 1.5 kilometers per hour. So now I need the current, and we know that R plus C is 2, so the current has to be 0.5. All right. Now, I made this last one extra credit because, boy, we struggled on this. Okay. 5 years ago, Tony was 3/5 as old as Cindy was then. 7 years from now, Cindy will be twice as old as Tony is now. How old are Cindy and Tony now? Oh, boy. All right, let's set this up so that we can organize our information. We've got Tony and Cindy. We've got their ages 5 years ago. We've got their ages now. And we've got their ages 7 years from now. I'm just trying to organize my information. So we'll make Tony's age now X, or excuse me, T, and Cindy's age now C. So 5 years ago, Tony was T minus 5, and Cindy was C minus 5. 7 years from now, Tony was T plus 7, and Cindy was C plus 7. I'm just writing some algebraic expressions because I know I'm going to need to figure out the relationships. So 5 years ago, Tony was 3/5 as old as Cindy was then. Okay, so Tony was younger. So Tony was 3/5 as old as Cindy was then. Okay, Tony's age 5 years ago was 3/5 Cindy's age 5 years ago. That's one equation. 7 years from now, Cindy will be twice as old as Tony is now. Okay? So 7 years from now, Cindy's age will be twice as old as Tony's is now. There's my two equations. So now I need to go through and solve this. So this one's going to be a little tricky. I do not like although this fraction's not going to be that bad. I can go ahead and multiply this out, right? I don't want to do that. I'm going to multiply this by 5 to get rid of the 3/5. And then if I multiply this by 5, right, let's multiply this through by 5. I get 5t minus 25. If I multiply this by 5, that will go away, and I'm left with 3 times c minus 5. So this becomes 3c minus 15. Subtract 3c, move it to the left. Add 25, I got 10. Okay, so now this, I think I can use substitution fairly quickly if I solve this for c. c is equal to 2t minus 7. So I'm going to plug in 2t minus 7 for c. So I get 5t minus 6t plus 21. Negative t, subtract 21. So t is 11. So Tony right now is 11. So that means Cindy is 2 times 11, which is 22, minus 7, which is 15. So Tony now is 11, Cindy is 15. And you can also check to make sure that these work. Cindy's age plus 7, so that's 22, is equal to twice Tony's age, which is 11. That's correct. And here, Tony's age 5 years ago, which was 6, is 3/5 Cindy's age 5 years ago. So we've got 6 is equal to 3/5 times 10, which is 6. So it works.